This is question 15 of Antiderivatives 2. Find the derivative or indefinite integral as indicated. Well, I think what it's really doing is find the derivative of the indefinite integral. So if we just think this through, and this looks like a real bear, and it actually is a bear to integrate. But if we do the antiderivative, we'll get a plus c. Then the derivative undoes the antiderivative, just like everything works in the math toolkit. And then we'll destroy the plus c. So we're actually just going to be right back to where we started. So we're just going to put in that original integrand of the original problem. So t to the 8th minus the natural log of t, go down into the denominator 7t plus 7, and that's it. So nice work. Now we can do that in the calculator, but it's a little bit more complicated than the previous problem. Now I have gone ahead and graphed my original integrand here as a function. Now, to graph it in the graphing mode, I have to switch the variable to x. So x is playing the part of t in here. And if we go back to the calculator page, shift minus to get the derivative, and I'm switching to x again so I can, when I get my antiderivative, I can graph that again. So now I'm going to put in the indefinite integral, then a fraction, x to the power of 8 minus the natural log of x, and down into the denominator 7x plus 7, tab, x, and ooh, that's a big fat mess. But we don't care. We're going to go up and copy that. Then go back to the graph page. Tab to graph another graph. Control V to paste. And they graph right over each other. So they really are the same thing. And one other way I can verify that is I can go back to the calculator and go var f1 of x, get out of the parenthesis, equals f2 of x. And this is like asking the calculator the question, is this equal to this? And it says true. So this monstrosity and this are the same thing in a greatly different form. And that concludes this video.